A very good day to all. I'm Hwai. Today I would like to present my study with title COVID-19 mRNA Vaccine Degradation Prediction using machine learning algorithms under the supervision of Dr. Azan Azamami binti Abdullah. The content of these presentations includes an introduction, methodology, result analysis, followed by conclusions and future work. Without further delay, let's start with the introductions of this project. In 2020, a significant threat to public health emerged. The novel severe acute respiratory syndrome coronavirus 2 or SARS-CoV-2 as its abbreviations, epidemic outbreak emerged. It is a single-strand RNA virus that comprises of four main structural proteins: the envelope, membrane, phosphorylated nucleoplastid, and spike. It will bind to the angiotensins converting enzyme 2 to enter the human cells. This disease was named COVID-19 by World Health Organization, and I believe everyone is pretty familiar with this designation. COVID-19 disease has infected more than 40 million populations and resulted in a mortality rate of more than 2.2 million as of January 2021. Till end of last month, it thrives to a number of over 103 million positive cases too. Although there are some vaccines recently approved, but it is undeniable that there are some undesired and unknown side effects after the injection. It is true that there is an antiviral drug remdesivir just approved in October 2020 by the Food and Drug Administration to treat COVID-19, and scientists are working hard to develop other effective treatments, but sadly, its supplies are limited. Aside from this reason, it is always better to prevent than cure. So, that is why we are focusing on vaccines that act as a preventive measure to control the outbreak. To control the pandemic from rampant, there are a variety of candidate vaccines under third phase of clinical trials, which is where the candidate vaccines will be tested with nominees for its effectiveness. mRNA-type candidate vaccines are one of the candidate vaccines that are most favorable due to its safety assurance, high efficiency, and low cost in manufacture. In other words, we are allowed to manufacture a large amount of highly effective vaccines within a short period of time with low cost. But this mRNA vaccine is pretty unstable and prone to degrade. Hence, this study is proposed to focus on the development of models and design rules using machine learning algorithms to predict the degradation rate of mRNA vaccine. Internal datasets that comprise of 6,034 RNA molecules will be implemented. The degradation rate at various locations, also known as bases, along RNA sequence will be predicted using models we are going to develop with machine learning algorithms. As mentioned, COVID-19 has spread speedily around the world. Both effective treatments and vaccines are currently under study and yet to be discovered. Even the most preferable candidate vaccines, the mRNA vaccines, more specifically, the mRNA 1273 vaccine has a drawback of rapid degradation. Differs from other vaccines that made up of kill or weaken viruses or antigens, mRNA vaccine is by injecting mRNA that sends an instruction to the ribosome to produce viral protein to be recognized by the body cells and learns to immune it. In our case, will be the S protein of SARS-CoV-2. It is worth notifying that these proteins are solitary, so they do not assemble to form a virus, hence free from danger. But unfortunately, its instability has become its biggest stumbling block in implementation. Therefore, a study on the degradations of mRNA vaccine is necessary. Environment conditions have a great impact on the degradation rate of the mRNA vaccines. As an illustration, under refrigerated cold chain transport conditions, the mRNA vaccine have a half-life of 900 days with 98% intact after 30 days. In addition, the half-life of an mRNA vaccine will reduce from 900 days to only 10 days if there is an occurrence of pKa shift even as small as 2 units. A temperature excursion to 37 degrees is predicted to lead the half-life to be reduced to 5 days, the same as when the vaccine is vaccinated in a human body, and it will further reduce to only 2 hours of half-life if there is a presence of magnesium ion, the usual in vitro transcription condition. You may have the idea to suggest to decrease the temperature, magnesium ion concentration, or the pH value to mitigate the situation, but sadly, it does not seem to be effective since degradation still occurs during the transcription process. Some of the researchers believe that this degradation problem may be solved with a second dose. However, the issue should not be disregarded since the mRNA candidate vaccine play a crucial role for the time being in controlling the outbreak before a final high-stability mRNA vaccine is done developed. Hence, it would be better to be clear on the degradation rate and stability of the vaccines under different conditions to enable for the measurements to be done. Of course, the same goes to the final vaccine. Therefore, this study is proposed to study the degradation rates of mRNA vaccine for COVID-19 with machine learning algorithms. Next, the methodology. Owing to the problem stated, the main purpose of this study is to develop reliable models that are able to predict the degradation rate of COVID-19 mRNA vaccine. In general, there are 6 main stages, namely data extraction, exploratory data analysis, feature engineering, data pre-processing, model predictions, and performance evaluation. For this study, the BPPS number file that holds the probability for each base of RNA to be paired is extracted together with the train and test datasets from internal database platform. Simple EDA approach is done to gain utmost insights into the datasets. It is fortunate that there exists no missing values in the datasets for each instances and features. A number of features in form of aggregate functions, max, mean, non-zero number ratio, standard deviations, and summation will be engineered from BPPS dataset to process the raw data into a more presentable and easier form features that are compatible with algorithms for modeling. However, as sequence length varies between instances in test datasets, dangerous features may have sprouted, and these dangerous features should be avoided from using since we can never assure that it may or may not induce the occurrence of overfitting and some other undesired problems. To overcome this problem, data visualization technique is utilized. Dangerous features that show different distribution compared to others will be eliminated. On the other hand, the data is cleaned in a way that noisy instances is excluded from feeding into the algorithms for training. The cleaning process has resulted the trained dataset to reduce from a total of 2,400 instances to 1,589 samples. To modify non-numerical data type data to numerical data type, label encoding is proposed to encode the 3 non-numerical features, which are the sequence, structure, and predicted load types in a way as shown in table by first splitting the arrays into single characters that resulted the number of instances to increase drastically from thousands to 100,000s, followed by machine learning algorithms for prediction with linear regression, a traditional supervised machine learning algorithms that study the relation between variables by fitting a regression line to data, and the tree-based learning algorithms like gradient boosting unit with GBDT boosting method to develop models. Since this study is in regression based instead of accuracy, prediction error is proposed with root mean square error as the performance matrix with formula as presented. RMSE is a negative-oriented scoring technique which implies the lower the RMSE value, the better the performance of the model. The table shows the prediction error for linear regression and LGPM resulted after evaluation with RMSE performance matrix. From the results obtained, we may deduce that LGPM is a better predictor than linear regression across all the classes in this study. The prediction error of LGPM shows a value of over 0.15 lower than linear regression. To conclude, LGBM is more suitable than linear regression for mRNA vaccine degradation predictions. Related research for this study is pretty limited. The one and only one that available for the time being is a study done by researcher Uncut Signal with LSTM, GRU, and GCN with 4K4 cross-validation. Comparing the performance resulted, the LGBM-based model performance developed even surpassed the models developed by Uncut Signal. Although the result for this study is laudable, the evident constraints of this study should not be overlooked. One of the biggest defects is the length of RNA sequence studied. In practice, mRNA vaccine for COVID-19 used to be in the range of 3,000 to 4,000 bases long, but this study consists only 107 to 130 bases. Hence, we may further improve this study by feeding the model with longer mRNA vaccine sequence and evaluate the performance error to permit better utilizations and reliability in the predictions. Besides, we may consider utilize tenfold cross-validations as performed in this study on the deep learning algorithms such as GRU proposed by researchers Uncut Signal in future research and observe the performance whether there is any improvement in predictions to provide an opportunity to compare the result between the deep learning algorithms and machine learning algorithms for COVID-19 mRNA vaccine degradation prediction study. In addition, GUI-based prediction tool is suggested to be developed. Thank you.